Okay, so far we have discovered some simple digital output, or we have discovered how to operate simple digital output examples, and I also uh, teach you on how to operate or to discuss in detail on how to use the input port, either digital input or analog input in detail. Again, like I mentioned previously, when we talk about the input, it's in practical it's related to the sensor, because in general sensor is the device that can sense the changing in the physical environment and convert it into electrical signal, whereby that electrical signal will become an input to the Arduino, which is why in general input port doesn't matter is it digital input or analog input, it will be connected with the sensor. In the slide there, I has list up several sensor that you can use with the Arduino. Okay, the existing sensor in the market that you can use with the Arduino. Okay, in this video lectures, I will like to share with you how does the existing sensor in Tinkercad here, the one in the black font there, how does it operate, how can you operate it in Tinkercad simulation. Of course, some of the example is not using the Arduino in order to operate that sensor. Actually, the sensor can be operate with the Arduino, but in some example in the Tinkercad it does not show how to operate it with Tinkercad, but I'm sorry, this does not show how to operate with Arduino, but you can, based on your creativity, you can use it or connect with the Arduino later if you want to do the project. Okay, now let's start with sonar sensor. Okay, for sonar sensor, you can type there in Tinkercad. They don't call it sonar sensor; they call it ultrasonic. Okay, but basically ultrasonic and sonar sensor is the same sensor, but in Tinkercad they call it ultrasonic. So, okay, instead of you choosing the solely sonar sensor, you can choose the one that already connected with Arduino, which is this one. Okay, so the purpose of sonar sensor is to measure the distance, the distance of the obstacle or object that close to this sensor. So if let's say if I run this simulation, then you later will know how to operate with the sonar sensor. So again, I open the code because in general this example is already included with the code on how to operate the sonar sensor with Arduino. So of course this code is inside this Arduino, and then okay, for sonar sensor it's a special sensor. Okay, and you can see the green line there is okay. The green line is connected with pin number 7, pin number 7, where that will become your, if you see the okay, if you see the codes there, the pin number 7 is used as the output, as well as input. Okay, this one is a special sensor where actually you need to set your pin 7 your pin 7 as input as well as output. Okay, Of course this is a little bit that's why I said that sensor sometimes is very complicated in order to operate, because some module or some sensor they provide with some library or some reserve function, where if you, let's say for example this one, if you want to use this ultrasonic sensor, then you need to familiar with to write this function. Okay, this is the user defined function, and then this is the one that the main function. Okay, we have a setup and loop, and then you call this function, where this function is actually this function. As you can see that this 7 here is referred to this pin 7, because generally if you want to measure the distance, you need to make this pin 7 become the trigger pin, where it will trigger some signal and it will send to, that's why this one become output, because in order for operate this one, you must send some signal from this port to the sensor to trigger this pin. Once you trigger this pin, then this sensor will read the distance from any obstacle that close to this sensor. It will provide the value for you. So if you are using this formula and multiply with the one that returned here, the one that returned by this function, then you can get the distance in centimeter unit. Okay, and then if you want to change the distance into inch, then you need to use this formula. So later you can explore this one. So I just want to run the simulation. So if I start run the simulation, of course to see the distance, they are using the printf. So that's why I need, because here there's a printf there, that's why I need to open my serial monitor. So that is the now there's a that is showing the distance now, the current distance of the obstacle. Of course I need to stop first, because this one need to drag a little bit, or I can maybe I just drag this one. Okay, I change the position there. So I start back the simulation. Okay, when you start running the simulation, you can see this is some dummy obstacle. Assume this object is in front of this sensor. As you can see that, okay, if I change the distance there, I mean the position there, so now the distance is changing, because normally this sonar sensor or this ultrasonic sensor will send back the distance, the physical distance here, into your Arduino. Okay, that is why when you manage to find, this is the function that return the distance. But of course when you do some multiplication with this number, you get this in centimeter. When you divide into 2.54, you get the unit in inch, and then it will print all the values there. So that's why you can see the value. Okay, so that's how you operate the sonar sensor or ultrasonic sensor. Okay, later you might think about, is there any obstacle in front of this sonar sensor? It is, let's say it is, you can put the selective structure there. For example, if the distance of the obstacle is equal or more than or below 77 centimeter, then you trigger the LED or you turn on the LED. You might have that kind of idea in order for you to do your project. Okay, to do your project that related to biomedical later. Okay, that is sonar sensor. Now we go for the tilt sensor. Okay, okay, in this example again, like I said, some example in Tinkercad does not set up or does not connect with Arduino. So in order for me to show that this tilt sensor is working, then I need to use this one. okay, but later when you want to use this sensor, you need to modify this setup by connecting this sensor with some with the Arduino. Okay, you can do that. Okay, but of course that's is depend on your creativity, and that is where you need to explore by yourself in order for you to do your project. Okay, but I just show the example here. Okay, in this example there's no Arduino, they just directly connected with some power supply. Okay, let's run this simulation. Okay, the purpose of tilt sensor is that when you tilt the sensor, it will change the tilt sensor is like your switch. Okay, where there, if there's nothing, means that it's an open circuit there. But if you tilt the sensor, it will close the circuit, and when it's closed the circuit, it will turn on this LED. So that's why you can see there's a LED there, means that when you have this in this position, which is that position, then it will turn off. But if you make it horizontally, so that's why you see this picture here, it will close this circuit or connect. Initially is disconnect this wire, but when you put it in horizontal, it will close this connection, or it will connect between this terminal and this terminal. That's why you can see the LED is turned on. Okay, that is one of the you can think about it how to use this sensor later for your biomedical application, because it's a quite good, because it can detect whether the sensor is in the vertical position or in the horizontal position. Because okay, this is one of the digital the output is in digital. It can be 0 or it can be 1. So this is an example of using the input digital input in Arduino.